Welcome back to our knowledge channel. Today we are going to discuss regression. This video is very detailed discussion on regression. Will show the both the picture. What is the advantage of having regression being done in Minitab with all the three type like linear, quadratic, and cubic. And if you happen to do this in Excel, what is the disadvantage or what is the pitfall you have that we are going to discuss. And two example we are going to do directly from Minitab is a free sample. You can also do it on your own and you can also have a practice. Let me show you the data set. This is the data set I have. This is the first data set I have. Energy consumption, whether it is relating to machine settings. Is in the machine settings time being taken is in relation with the energy consumption. We're going to do all the three. You can see here linear, quadratic, and cubic. And generally, we tend to do it in linear. And for example, in this very case, the linear is it shows that it is not correlated, right? That means machine setting is not correlated with energy consumption, right? So that means we may tend to lose the point because if you do that in the other type of the regression like quadratic and cubic, you may find that it is a strong correlation, right? And not only that, we are going to learn this, all the settings, log and all that we are going to learn. And this is the first video we'll be talking about it. And then next one, and the second part of the video will talk about the density and stiffness is in correlated. And we can do it in all the three model like linear, quadratic, and cubic. And isn't only necessary to go through only linear or all the time we have to do it all the three type of regression that we are going to do discuss in this video. Let's go and take the sample directly from Minitab. In the Minitab, you will find this is a sample and let me show you where you can find it. You can go to file, you can go to open worksheet. In the open worksheet, click on look in Minitab sample data folder. EXH. Generally, in all the EXH, you will find lot many examples, right? But here we are going to discuss mainly on regression. So you take this one, give OK. And since I have already opened, let me reopen again. So this is the one. So we are going to discuss heat flux isolation and heat, east, west and all that. There are a lot many data set is there, but mainly we're going to discuss only energy consumption and machine settings. Only these two variable we are going to discuss. The upcoming video will be discussing about multi-regressions, everything. Now we are going to discuss only single regression of machine settings and energy consumption. So go to stat and go to regression. In the regression, you will find fitted line. This is for the general one. If you have only two variable, if you have more than two, that is multi-regression, you can use this one. So since we are going to do it only energy consumption and machine settings, we will be sticking with fitted line plot. Have a click on this. I'm going to give F3 so that it will clear up the window. And I'm going to take that energy consumption is an output, right? It's a dependent. Energy consumption is an output and then predictor is X. That X is you will find in C10 machine settings. So machine setting is X, Y is response, that is output. And I'm going to do it linear, quadratic and cubic. Let's start with the linear. You can also ask for a residual plot also as well. That's okay. And you can also in the options always you ask for log 10 of y because if you want to do it both, but you can do it, but log 10 y we can easily get that inferences. Otherwise, the graph will be so crowded. And then you can also get the confidence interval and prediction interval. We don't need confidence interval is okay. And if you wanted to have prediction interval also, you can have that is called PI. Confidence will call CI and give OK. And if you wanted to store, we are not gonna store. We can directly show in the graph itself. Give OK. So this is the residual plot. First one normality, it looks to be normal. and the fitted is almost like horizontal. This is good. Histogram is nicely it has come, versus ordered is good. So as far as the variability is concerned, this is okay. And now let's see that this is the fitted one, and which we did the linear one. Linear shows that there is a weak correlation, right? 1.3 it shows, and then adjusted it is 0, right? And we can also, if you don't want the log, we can remove the log also. Let's say you don't want the log, can just get rid of the log also. Let's see how much we got. So we got, since the residual plot we have turned on, it is coming up, and you can see that it is showing like 2.3 without log 2.3. Let's see the same thing in the other model, and then we'll compare with the Excel so that we can see. This is the linear one. In linear one, we are getting like 2.3. That means the machine, the energy consumption is not related with machine settings. So these two are not directly connected. So I'm gonna give Control E. In the Control E, I'm gonna give quadratic, give OK. And again, I don't need this residual plot. I have already checked. So I'm gonna deselect the residual plot. Okay, give OK. So you can see here now this is a strong correlation because more than 70% is a strong correlation. The standard deviation is 6, and you can see that machine time, it has given like curvature has been there. You can see if it is 10 minute, around 10 minute, the energy is consumed is 20, and if it is between 20, it takes a less one, right? And if you, so that means the middle path is better. So machine settings is 20 minutes done. So that means time, energy also less. If you are doing, if you're taking more, and this also is getting correlated. So this is the fitted one. Same way, if you want log, you can also turn on log, so that will give more inferences, right? You can just give OK. And you can see here, so this is in the log. Now it has, the situation has improved. So the standard deviation has came down, and then R squared 93.1, strong correlated, adjusted is 91. And you can see this is a confidence interval and this is prediction intervals, right? So both, so you can see it is, that means it both are correlated. It is opting for the machine setting 20 and all that, right? Similarly, the same way you can do it for cubic also. Give OK. And cubic along with the log, you can see here 95 and 93. And it also has given that nice curvature is there, and so on. So this is the all about the first example which we have done, right? The same thing which we can do it in the Excel also as well. In the Excel, as you can see here, this is the two variables what we have, and you can go and just go to Analyze Toolpak, that is data. Under the data, you have Analyze Toolpak. Just click on Analyze Toolpak, and you have a correlation, right? So, and then you also have a regression. So we'll take directly regression. In the regression, so we have this model like Y is our machines, I mean, energy consumption, and I'm just entering it. X, you can see X is machine settings. Okay. And then we can get it confidence interval also. And you can store in the somewhere here we can store. If you want, you can residual plot. We have already checked. Normally plot we don't need. So we can keep it here. Enter. So you can see here. I'm just moving here. Yep. You can see here. This is the correlation value it has given, and R square value is 2.3%. The same value we have got. Whenever you're doing it in Excel, so default it gives only the value of linear regression it gives, because we have also done the linear one, right? So let me do it again. So in the linear, Control E, and I'm switching back to linear. I'm not turning on the log, and without log linear we are doing it, and you can see the value is 2.3, exactly the same value is there, and but it is not correlated at all, right? So but the Excel, it gives very fast, but only drawback of the Excel is that it will not be able to do in other model. For example, let's say if you wanted to change, like how Minitab is giving the flexibility to switch to quadratic and cubic, that flexibility you will not have in Excel. So therefore, when you're doing it in Excel practically, you might conclude that this is not correlated, and then you may end the analysis. But always do not rely on only linear regression, because some variables can behave linearly, some are quadratic, some are cubic. So therefore, you have to perform all other tests in order to conclude your inferences. So this is the one. And similarly, let me take another example. Now here we will be interested in density and stiffness, and we are gonna do it this example in particle board. So what I'm going to do, you will find it in Minitab also. So this is also there in Minitab. So you can go to File, Open Worksheet, look in Minitab Sample Data, look in Minitab Sample Data folder, and you can type particle board. Give OK. So let me reopen again. So this is the data I have. So now I'm gonna study only density and stiffness, and we can also see any other things. So we'll do it in Minitab first, and we'll also will do it in Excel. So let's do it in Minitab first. So regression, fitted one, give F3, and we are gonna study that how much stiffness if we apply density as a predictor is density. We will go with the linear with no log. Okay, give OK. And this is the one. That means there's a strong correlation, right? And I think so when we get the answer in linear, you don't need to further go. If you wanted to go, it's fine. For example, let's say quadratic, if you go, quadratic also says that is strong correlation. And cubic, if you show, it also gives that strong correlation, no problem. And in that, you can also get that log also, no problem. So, but only caution point is that whenever you're dealing with the linear one, and if the linear shows that it is not correlated, don't end with that. You can switch to, in the previous example, we saw that we switched to quadratic and cubic and we got the best result. So therefore, we can do the same thing. Let's do it in this one. So temperature also we can just change. Let's say instead of stiffness, I will say temperature. You will find whether it is correlated or not, right? It's not correlated. It has beautifully, it has come like confidence interval and then predicted intervals and all that. It is not correlated. Neither in linear, you will not get it also, right? Just 2.6, less than 1%. So density and temperature is not correlated. Similarly, we can also switch to the multi-regression that I'm going to explain in the upcoming videos as well. So this is the one. Same, we will do it in Excel also as well. So what I will do, I'll just click this. I mean, I will go to data. In the data, you will find data analysis. In the data analysis, regression. And in the regression, you can give a range that output you can see here. In the y is our output. Y is nothing but our stiffness. Have selected the data, enter, and similarly take x. X is nothing but density. Okay. So okay, let me do it again because it has pasted the value on top of it. So what I will do, I will just delete entire value and let me do it again. Go to this and take this data. We are already done in the Minitab. We are gonna do it in Excel. Now what I will do, I will go to data and analyze one regressions, and then you will find that y is the stiffness, and x, just take the x is our density, and then you can get the 95% confidence. We can store the values somewhere here in F1. I will store, and I will ask for the normality plot, and I'll ask for residual plots also as well. right? But residual plots, we'll see how it comes. Give okay. So the residual plot that has not come well with the Excel, but we'll see the values here. So it is 84.4, right? R square adjusted is 83, slightly lesser than that. Is always is there due to error, right? So this is there. The same value we got it in the, this is linear one because many Excel takes default as a linear regression. So we can see the value in the, we'll compare the value in the Minitab. In the Minitab, control E, I'm switching back to this linear, and I will keep the predict response as density, sorry, response as stiffness, and give okay. So I'm just removing the lock, and let's see how much value. 84.5, 83.9. Exactly the same. 84.5, 84.5. If you happen to have only one decimal point, 83.9, 83.9. And this you can see that residual plot, degree of freedom, sum of square, all that F value, so which is significant, all that observation, predicted value, percentage, probability plot. You can see that probability plot also you have got it, and all other value also we have got it. So the key message is that don't, sometime in the example 2, linear regression has helped, but the example number 1, linear did not help. The only thing is what it helps is quadratic and cubic. So it depends on the situation, but you have to execute all the three in order to have a best interpretation. So thank you so much. I hope you find it useful. Thank you so much.